Hello friends, this video on areas related to circles part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 7. Let's take one good example. A horse is tied to a peg to one corner of a square shaped grass field. This is a square shaped grass field. 15 centimeter by 15 centimeter is the dimension of this field. There is a horse tied from here, and the 5-meter long rope. This is the rope. From this rope, this horse is tied to one end. Find the area or the part of the field which a horse can graze, and also we find the increase in the grazing area if the rope is increased from 5 to 10. So what you do? The question says this is a square field. This is a horse here. This horse is tied to this string, and this horse can move. So if you see the horse, the maximum area horse can move is like this. See once again, the maximum area it can move is like this. This is nothing but a circle. You see, this is nothing but a circle. How I will draw? You see this area. This is the path the horse will follow, right? The maximum path. And this is nothing but a circle. See, this is the circle. This is a sector actually, sector of the circle, where this radius is 5 meter and this angle is 90 degree. Why? The square. So what did you find? We have to find the area which this horse can graze. This horse can at the max graze this area. Correct? Try to understand. This is a square field where the horse is tied with a thread, and the maximum area I can graze in this area. So if you see, this forms a circle where actually this forms a sector where theta is 90 degree and the radius is 5 centimeter. So if you find the area which she can graze, so we'll say that area of sector is nothing but theta by 360 pi r square. Theta is 90 by 360 into pi. Let me take 3.14 because r is 5, it won't get cancelled anyway, into 5 into 5. So this gets cancelled 4. And if you solve this, what you get is this value is nothing but 119.625, and it will be meter square. Why? Because it is meter and we are talking about area is meter square. So 19.625 meter square is the area which the horse can graze. This is my answer. First part is done. The second part says that find the increase in the grazing area if the rope size increased from 5 to 10. So instead of 5, it is not 10 here. The horse is like this here, 10 centimeter. And now the horse will graze this area. We are talking about the increase in area. This star one is the increase in area, because the earlier was this was the area, the dash one, and now it is the total area. So the increase is the star one, and that is what they are asking for. Correct. So here also, if you see again, it's a sector with radius as 10 meter now. This total is 10 meter. Theta is still. So we'll say that increase area is nothing but theta by 360 into pi r2 square minus theta by 360 into pi r1 square. Correct. So if you see, theta by 360 pi is common, that is theta is 90 by 360 into pi, 3 is common, by r2 square minus r1 square. So r2 square is 10 square minus 5 square. This is my value. So if you solve this, what you get is 58.875 meter square. Why meter square? Because unit is meter, talking about area, so it is meter square. I'm not solving this, you can solve it. But the concept here is, in the square, this horse is grazing the grass. The angle is 90 degree and the maximum is this area. This is a sector. You find the area sector. The question says the length of the rope is increased It's a new sector here. So you define the area of new sector minus area of old sector to get the increase in area. One more question. The brooch is made of silver wire in the form of circle with diameter 35 millimeter. Here the unit is made in millimeter, please note. The wire is also used in making 5 diameters which divide a circle into 10 equal sectors. So this 1, 2, 3, 4 and 5. Because this is same, right? So these 5 diameters are used to divide this brooch into 10 equal sectors. Also, the wire is used to create this length. This length, if you see, right, this is done using the metal wire. So not drawing proper, but this is the length actually. So what we have to find? We have to find the total length of silver wire required. So if you see, the wire length required is nothing but the length required to create 5 diameters plus the length required to create circumference of the circle. So if you see, I am doing part 1. Total length of silver wire required is nothing but 5 into diameter, that is there, this one, plus circumference of the circle. Circumference of the circle, that is 2 pi r. What is the value of r? R is 35 by 2 because 35 is diameter, right? D is equal to 35, R is equal to 35 by 2. 2 pi into R, that is 35 by 2. So this is the total length required. So let's solve this. That is nothing but 5 into D, D is 35 plus 2 into pi, I'll say 22 by 7 because 35 can cancel. 35 by 2. 2 to cancel, 7, 5, 35. This comes out to be 175 plus 110, and there is nothing but right here 285, and the unit will be millimeter. Why? I'm talking about length, and it is millimeter. So 285 millimeter of the silver wire is required to create this. Now the question says we have to find the area of each sector of the brooch. So we'll take one sector. Let me take a better one. This is overlapped here. So let me take this sector. So this sector, area of one sector, we have to find this area. So first, to find area of sector, the formula we know that area of sector is nothing but theta by 360 into pi r square. R is something we know, 35 by 2. Theta is something which we don't. Correct? So let's find the value of theta. Now since the question says there are 10 equal sectors, that is there are 10 things like this, 10 sectors like this. Total angle is 360 degree. Correct? Total angle is 360 degree. And there are 10 such sectors. So each sector will be 360 degree by 10, that is 36 degree. So each theta will be 36 degree. 36 degree. Each will be 36 degree. So I got the value of theta, that is 36 degree. So I'll put this as 36 by 360 into pi, I'll take 22 by 7 into r is 35 by 2 into 35 by 2. If you solve this, this gets cancelled. 5, 36 by 10, 5, 2, 2, 11. So this comes out to be 11 to 35, that is 385 by 2 into 4, 2 is 4. And the unit will be millimeter square. Why? Talking about area, and the unit is millimeter. So the area of each sector is 385 by 4 millimeter square. So we have got both the things, length of the wires required and the area of the sector, each sector. Let's take one more example. The question says the umbrella has 8 ribs which are equally spaced. Assuming umbrella to be a flat circle of radius 45 centimeter, you have to find the area between 2 consecutive ribs of the umbrella. So if this is the umbrella, top view, if you see this is the one, and there are 8 ribs, 1, 2, 3, 4, 5, 6, 7, 8. We have to find the area between 2 consecutive ribs. That is, if you take this rib and this rib, we have to find this area. If you see properly, this is sector. Correct? This is sector. So we'll just use the area of sector. We'll use the formula of area of sector. That is nothing but theta by 360 into pi r square. R is something which is known to us, 45. R is equal to 45. Theta is something which we don't know. Correct? So we have to find the value of theta. So if you see, the total angle is 360 degree. From here, if you see, this angle is 360 degree. And now there are 8 such sectors. Correct? So each sector will be 360 degree by 8. Correct? This comes out to be 45 degree. So each sector will be 45 degree each. 45 degree each. So my value of theta is 45 degree. I got it. Very simple. Let's put the formula. Theta is equal to 45 by 360 degree into pi. Pi is, I can put anything, and put 22 by 7 into r is 45 centimeter into 45. Correct? So this gets cancelled. This is by 8 and this is 4. This is 11. So what we get is 45 into 45 into 11, that is 22275, and 7 into 4 is 28. The unit will be centimeter square because it is area and this is centimeter, so it is centimeter square. And this is my answer. So the area of one sector is 22275 by 28, or we can say that the area between two consecutive ribs is 22275 by 28 centimeters. Let's take. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.